Alright, we're on page 96. So we talked about, on page 94 and 95, we were talking about operations within the, with integers, so PEMDAS, and then anytime you have subtraction, you turn it into what? Addition of the, so if you have 3 minus 4, it turns into
3 plus 4.
3 plus what?
3 plus negative 4.
Yeah, negative 4, and you put the negative 4 in parentheses. So, and like if it was actually 3 minus 4, you would do it, but usually it's something more like 3 minus 4 times x plus 2, or something else like that. But we'll get there when we get there. So page 96 is talking about application to real world problems, what we're doing. So example 13 on the top, Angela is making a paper box using a piece of rectangular paper. The dimension of the rectangular paper are 9 by 12 inches. So I do the right one on the right side. Yeah, so this one's 9 inches. This one's 12 inches. To make the paper box, she cuts 4 identical rectangles from the corners of the paper. These are cut off rectangles that are shown in the diagram on the right. What is the area of the paper that remains after these rectangles are cut off? So this is what it looked like before. And then it says she is cutting, let's see, 4 identical rectangles. So it tells us this is 9 inches. Oh, I'm gonna go back and just do this. And we're gonna say more or less that looks about the same thing, right? And then it also tells us, hey, this and that and this and that are the same. And then it tells us these, this, this, and this. Now, what do those little lines mean? Yeah?
Every single side is the same.
Yeah, so these right here, so this little imaginary rectangle right here, this right here is the same length as that, which is the same length as that, which is the same length as that. So if you see 2 dashes, that means that that is equivalent to the other. If you see 1 dash, then that means that's equivalent to the other 1 dash 1. Now, if it's got the 2 dashes and 1 dash, you know that that's a rectangle, which means that this would be the same as this is the same as that. Same, 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 and same. So all of those are going to be similar. We know that. Let's see here. So if this and this is the same, what does that make this?
3.
What? 3? How do you know?
Oh, because we divide everything by 3 numbers.
Look at page 96. On the right hand side, it says this is how many inches? 8 inches. This is on the right hand side. Look at the 3D thing on page 96. It says this is 8 inches, and it says this is 3 inches. So if that's 3 inches, then that makes this 3 inches, because if this is similar to that, and this is similar to that, which are similar to each other, that's going to make this 3 inches as well. And if this is 3 inches, then there's 6 inches of these 9 to go to these 2, which makes each one of these triangles. Let's draw a mini little rectangle. This side is going to be 3 inches. Alright, and if this is 12 inches and this is 8, how many inches do we have left for these 2 right here? 12 minus 8. What's 12 minus 8? 4. So we have 4 inches to go between these 2, which are both the same size, which means 4 divided by 2 is 2. So, I mean, this should have been drawn a different way, so that it doesn't look like this side is shorter than this side, but every single one of these rectangles, 1, 2, 3, and 4, every single one of them is 3 by 2 inches. And that's how we use what we know. Hey, this is 8, this is 12. These are the same, which means that there's 4 inches left to go between these two, so that makes each of them 2 inches. And if you find out one rectangle, you find out all the other ones, because we know all of them have this is equal to that, this is equal to that, and all four of those rectangles are the same. So then we can say, hey, if we want to find out the area of all of this, we have to figure out what is the area, 12 times 9, and then we have to, nope. We want to find out the area of all of this filled in stuff right here. So if I have all of this yellow stuff right here, because she cut off the other stuff, we want to know what's the area of what she has left. How do we figure out what the area of what she has left is? If she didn't cut that stuff out, then it would be 12 times 9. How do we figure out the area of what she has left and what's in yellow?
So,
Yeah?
9 times 8 minus 4 threes.
Minus 4 threes. Minus 4 times 12. 4 times 3. So 9 times 8. Oops. I'll do that in. Let's go black. 9 times 8 minus 4 times 3, you say?
Yeah.
Okay. Anyone else got any other ideas? So he's saying 9 times 8. That's this part right here. So you take 9 times 8. And then you subtract 4 times 3. So that means that, because this is 9 times 8 already in the first place. If that's 9 times 8, then you subtract it. That means the area of this has to be smaller than what it actually is. So it's not 9 times 8. Yeah, you're on the right track. What do you think?
Well, all you would really have to do is find the area of the whole thing and then subtract the total of the missing parts.
Boom. So what's the area of the whole thing? How do we figure that out?
9 times 12.
Yeah, 9 times 12. Oh yeah,
Nice.
I forgot I gotta do that. 9 times 12 minus, what's the area of one of them?
6.
3 times 2 is 6. And how many of them are there?
4.
6 times 4, so this is 24. 9 times 12 is?
108.
Yep, 108. 108 minus 24.
86.
86, no. 80. 108 minus 24.
84.
84. And what's the label? And we haven't written up on the board here yet.
Inches.
Inches, it's area, so that makes it inches squared. So that's how you figure out, hey, what's the total of all the other stuff? And figure it out from there. Now, you can use this with variables if you want. Just a hypothetical way, because I know that you're really interested in it. You could say, hey, it's 8 plus 2x times 3 plus 2y, and then figure out what x and y are from that. That's going to complicate the process. Just use what you know, go from there. So if that's how you figure that out, I'm going to give you guys 2 minutes. Do page of 96. Joseph drew a hexagon on a 3-inch square of paper. Okay, so we know this is 3 inches by 3 inches. It's a hexagon, and we know that so, based on what you know in there, take a look at, I'm going to give you guys some time. Try it, see where you can go. Remember, use what you already know. The fact that all 3 of these are the same, these 2 are the same, that gives you a lot of clues. Alright, what ideas do we have? Where do we go? Can we find the area of everything? Yeah, that's easy. 3 times 3. Whoops. So 9 inches squared is the area of the whole thing. Can we subtract off the other stuff that we cut off? Which is how do we find the area of these? Do they tell us? Can we figure out what the area of one triangle is? Yeah?
So they said the height of each triangle is one half the length of the paper.
Yep.
And
Because we know that this is 3, it's got 2 different lengths.
one half of 3 would be 1.5.
Yep, so we have 1.5 or 1.5 for the height, and what about the base?
The base of each triangle is 1/3 the length of the paper, so that would be 1.
Boom. So we have 4 triangles, right? So there are 2 different ways to do this. One, you can say, I'm going to figure out what type area of one triangle is and then multiply that by 4. Or you can think of, hey, if I put this triangle and this triangle together, they make a... Here's one triangle. Here's the other triangle. You put them together like that, they make a rectangle. And instead of figuring out the area of 4 triangles, you could figure out area of how many rectangles? 2 rectangles. Now, the area for the formula for the area of a triangle is base times height. That's rectangle. So if it's a triangle, which is, half of it, then you would do base times height divided by 2. Now, personally, I like to think of it as it takes less steps if you think, hey, I'm putting these 2 triangles together, these 2 triangles together, and I can get 2 of the triangles. So I would do 1 times 1.5, which is 1.5. 1.5 times 2, which is 3. So it's 9 minus 3 is the whole thing. Now, if you want to say base times height, and you base times height over 2, and you end up doing 1 times 1.5 over 2 times 4. Guess what? Ends up being the same thing. Here you can cancel this out. This becomes 1. This becomes 2. 2 times 1.5 times 1, same thing. You're going to get 3 for the area of that other stuff. 3 minus 9 is, 9 minus 3 is 6. And is this one inches still? What's the label?
Inches, yeah.
So inches squared. And you guys can start your assignment.